So, welcome everyone. I'm happy to welcome you here at the University of Basel. My name is Nicolas Gerig. I do not have so many slides prepared, so just orally my background is also in sports training simulators and rehabilitation engineering. I did my PhD at ETH Zurich and Baldur's University Hospital, so it's a very close connection despite I left before you joined. So in my past I was working on a rowing simulator, so it's a large human-machine robot with very dynamic movements and very strong motors that could break a human spine. I then moved over trying to transfer these learning concepts and assistive strategies that we had to a arming robot, which was commercialized as Ameo powered by Okoma. I worked a bit in the field of automated training success evaluation and then predictive models that help the therapists to choose other training support, and then finally moved here to the University of Basel, where I'm working more in a surgical feasibility research, I would say. So most of the projects that we do at the Berman Lab are in an early stage, where we are looking at technical feasibility. So how can we make systems that support, what can we do, what accuracies can we achieve, can we make minimal invasive laser ostomy happen. So my job here is, again, mostly the projects of human-machine interfaces. We have presented by my PhD student Morali Kana admittance controller using a commercial device, a KUKA LVR IVA with our own custom handle to do hand guidance in 60 degrees of freedom. The challenges, if you look at my bio, is I moved from very strong, very dangerous robots with a high dynamic to quasi-static movements with high precision, so it seems everything became easier, but it did not. The problems are very similar. And the major problem, I think, is, besides regulatory things and issues that I personally had when suddenly patient data becomes part of an algorithm, how this is being handled here is just complexity. Complexity and openness of companies. We do not want to redevelop the wheel. If we are in the surgical field, we have requirements, we figure out what is needed, and then we do not want to build all the robots from scratch. So we want to use what is on the market, and the big problem we have there is learning curves of manufacturer-specific knowledge, and do we use those devices according to their intended purpose, or do we lose all the certification? And so this is one of the biggest challenges I face supervising my PhD students. They have to provide scientific output, so they have to develop a system. They have 3 or 4 years of maybe no output, and they're still expected the same amount of scientific outputs as non-engineering students. We don't have any funding for technicians. We don't have funding for technical workers that also keep knowledge in the academic labs. This is a big challenge. I am very happy that we have events like the Innovation Booster, and I'm very happy that at the Berman Lab, I, together with Morali, just received an NTN Innovation Booster to continue working on this project where we do endoscope hand guidance steering with a Stäubler robot, and I'm really hoping that they are a bit more open on the interfaces we can use. And the second part is we also got a float from VHStim. I don't know if you know that company. It's a company that Georg helped to put the product on the market, and the technology is based on the rowing simulator that both he and I did our PhD on. So the very unique situation we get there is that we will be able to hot swap the control cabinet from a CE-certified medical device for therapy to our own research code base where we can do whatever we want. So I hope that in the future the companies also see the gain in these kind of situations, and that with those kind of collaborations we can reduce the complexity and the problems we currently face. I'm open for any questions, and to achieve the state where we get the certain requirements, most of the time we have to have a working demo. So there's a lot of developmental work until the key stakeholder can finally tell us or figure out what he actually needs. So keep that in mind. With that, I would like to thank you for your attention and hand over to the next speaker, Stefan.